Hi, I'm Rich Johnston. I work for Arqiva, who you probably have no idea who they are. Does anyone know who they are? Oh, smart arse. It's all right. There's a few people know who they are. The guy I was talking to at the break had no idea who we are. Anyway, we broadcast a bunch of radio and TV in the UK, but not many people know about that. And I've worked there for 13 years, mostly in the technical space on analog radio, digital radio. I used to do some design of radio systems, and now I head up the business unit for commercial radio. So my customers are everybody but the BBC. Right, we're going to talk about a bunch of technical stuff. I know it's been, quite quickly as well. So we'll see how we go. So you've got some audio in the studio. You've built it. Lots of people talked about that stuff already. You now need to get it up to a transmitter or more than one transmitter, perhaps. And for that, you're going to need some circuits. This is an odd graphic. So lots of circuits often are analogized as pipes because, you've got a big pipe, lots of water can go through it, got a big circuit, lots of data can go through it. And you used to have to worry about, right, so you got to get up to the transmitter, you're going to need at least one circuit, but you might want two because the first one might break, and that's a big problem if you've got adverts going out. You might want to worry about the length of the pipe, less so these days. But back in the day, it was all distance dependent, and price was based on how far the circuit goes. Today, not so much, because it will likely be an Ethernet circuit that you're buying from BT. It's not distance dependent, the price. Anyway, building all that up, you figure out, right, how many circuits am I going to put there, and how resilient am I going to make it. That's going to feed into the cost, which is that box in the bottom right-hand corner. And what you're trying to avoid, as can easily be seen here, is a lightning-powered child digging up your, all the, all your circuits. That's obviously actual lightning, an actual digger going through circuits. And the more money you spend on, how you get that signal up to the transmitter, the more likely it is it's going to be resilient and not be broken. This is kind of meant to be a kind of visualization of how all that works together. So you can, buy loads of circuits, you get them separate, all that kind of stuff that I was just talking about, but it's going to drive the cost, and you need to know what's kind of suitable for your business or your radio station. So some of the physical, the underlying technology that'll get it up there will be potentially satellite. If you need to get your signal to the entire UK, satellite is brilliant. You've got to get it to hundreds of transmitters, it's great. If you need to get it to one transmitter, that's bloody expensive. Radio links are it's sort of a wireless technology, so you have kind of two dishes pointed at each other. That's kind of it's quite expensive to build, but then it's cheap ongoing after that. And then we've got just circuits in the ground. So you're not going to put those circuits in the ground necessarily, but you'll buy them from people like BT. By the way, when you do, they're going to take way longer than you expected to build it. It's the most critical thing in your project. Always say you don't know when the circuit's going to land when you're doing a project. That's always going to be your critical path. That's true. And it also might end up in a very expensive dig at times as well. Right, so now you've got some circuits that are going up to the transmitter, and you have your configuration, whatever that happens to be. You probably want to, first of all, it's going to be an IP circuit these days, so it's always IP these days. Kind of forget about any old technologies, if you've even heard of them, looking at the age of some of you. So you'll need to, and you'll probably want to compress it because, bit rate costs money, so a smaller circuit costs less than a big circuit. And there's also, most codecs these days have a bunch of options that once you've squeezed it down, not thrown away too much of the audio quality, and bearing in mind you don't need all of it for FM, which Martin will come on to in a moment. It just makes more sense to send a smaller payload. You're less likely to get it corrupted and things like that. Okay, this is a very kind of whistle-stop tour of all this. There's a lot goes on in this space, but bearing in mind it's going to be IP, you've got a couple of different, options there. Are you just going to send it as one stream? If you send it to multiple transmitters, do you use multicast, which is just a kind of more efficient way of using IP? And then there's a bunch of stuff inside the codecs which will help kind of ruggedize it across across your circuits, which will lose packets as well, by the way. And then there's a whole bunch of kind of like just sort of made up terms that are inside. That's true. You'll hear it at IBC if you ever go there. It's just a bunch of stuff you've never heard about, which people claim is technology, but it's probably just someone else's idea that they've re-implemented. But anyway, there's a bunch of applications which will help you just ruggedize that transport across. And MPEG-Dash is mentioned there just simply because it's another different type of technology that helps to get your audio to somewhere. BBC iPlayer uses it. If you're using cellular stuff, 3G, 4G, that might be a good thing because it's quite good at buffering lots of stuff very quickly, and then it'll play it out until it gets another chance to buffer some more. I'm going to pass on to Martin.
Thanks, Rich. Right. You heard earlier about audio processors. Why do we need to process? Well, you need to process because it's very quiet. Suddenly you get very loud. All right? That's what happens, and that's what audio processors do. And the dynamic range, the signal-to-noise ratio of your transmission system, and importantly, as all these people over here will tell you, the station sound is everything. You've got a certain radio group which the MD allegedly sits in his Range Rover, turns up his fancy all singing hi-fi in his Range Rover and says, yes, make it louder. Make it louder. Yes, that's it. He wants to try listening in a Ford Escort. Right. CDs have a dynamic range of about 90 dB. Well, they used to until music producers started compressing the originals, for goodness sake. Quentin'd have a fit. FM transmitters, signal-to-noise ratio of 54 dB. Therefore, you've got a mismatch. What happens to everything that's very quiet? You have to compress it because you've got the mismatch. And you have to limit it. So, station sound. People of my age remember equalizers in your hi-fi system where you could control the bass, the mid and the treble. Fantastic. Audio processing. Most of the modern processors, about 7 bands. Somebody's going to tell me the new ones have 9. No, still 7. Right. 30 hertz, and I've got 20 kilohertz there. All you smart people will say, but FM only does 15 kilohertz, DAB does 20. Apart from the mono services, which only do 11. Or how to drive your listeners to other stations. If you overprocess, it gets very wearing on the ears, even these old ears. All right? It gets wearing. People will suffer fatigue, and they will tune out. There is research that proved it. Certain people don't want to listen to it, won't read it, and they're normally managing directors and producers and not engineers. Lovely sound of Radio 3. Something we all love. And then you get slightly different, slightly louder, more punchy, all achieved with audio processing. Right. Here's a visualization of audio, because you can visualize it, yes. That is uncompressed audio. Somebody, Cool Edit, or is it Audacity? One of the two. Cool Edit. I can't remember. We did this slide 5-6 years ago. So that's what it looks like. You can see the peaks and troughs. And this is what it sounds like. And when you put it through a processor, it's like this. What happened to all those deep troughs? They've disappeared, apart from a couple. And it sounds like this. That sound nice, sweet? Anyone not notice a difference apart from me, because I'm spent too long stood 3 foot from loudspeakers at rock concerts? Right. No? Double tapped it. There's the two together so you can see them side by side, okay? That's what audio processing does. That's what it's for. So you've got your audio, you've processed it. What is a transmitter? Well, it takes the audio and turns it into... Anyone?
Is it RF, Martin?
RF, yeah. We'll turn it into RF, right. Radio frequency. You've got to transmit it, so it's got to become a radio frequency. Audio to radio, but how do we do it? Well, it's FM. It's flaming magic. Right. We start on the left-hand side. You've got a microphone. And this is where, as Quentin said earlier, you don't need all these racks, rooms, and everything else. You can just have a microphone, an audio amplifier, a modulator, an RF frequency generator, and an amplifier, and an aerial, and you've got a transmitter. You don't need all these fancy racks, rooms. So what I'm going to do now is we've got 3 hours of maths. All right, yeah. But we're going to achieve that in about 2 minutes. So what is a modulator? How does it do it? Before I start, anyone here done RF at university, anything like that, apart from some of you?
You did see the response whenever you were looking for the answer, RF, right?
Yeah, right, that's good. Right, I can lie. Right, so I'm going to simplify this. What we're trying to do is superimpose the audio on the RF signal, because that's almost what you're doing. What happens is, we're going to say, anyone know a radio station on 100 megs? KISS, yeah. Right, I pick 100 megs because that's nice and easy. Our generator number 3 on that diagram is operating at 100 megahertz. Our modulator is only going to get mono, for sake of argument for the moment. And we're going to take the audio, feed it into the modulator at the same time the RF goes in. What happens is the amplitude of the, I've got a laser pointer, the amplitude controls how much the frequency moves, how much it deviates. And the frequency of your audio, so if we work with a 1 kilohertz tone at the moment, just a pure tone, it means the amplitude will go up. As it goes up to a maximum, you will move your frequency 75 kilohertz, either positive or negative, above and below 100 kilohertz. Megahertz, thank you. Yeah. Someone's listening. But what rate will it do this? It'll do it at 1 kilohertz, 1,000 times a second. So it's going like this, fairly slowly, but like that rather a lot. Okay? And that's modulation in 2 minutes instead of 3 hours. A lot of maths. So that was your transmitter system, how it works. Audio input audio processing we've done. In your audio processor will probably be a stereo generator that takes your left channel, your right channel, mixes them up and puts it out, not as a left channel and a right channel. Oh no, if only it was that simple. You've got a left plus right, which gives you your mono signal, and a left minus, and a couple of other tricky bits of maths, which we don't do maths here, but needless to say, 0 to 15 kilohertz, 19 kilohertz for a pilot tone. Hands up anyone who's ever seen the little red pilot light come on the radio that says it's stereo. Yeah, see, so in a museum, yeah. Right. So you've got the stereo, it goes into the modulator, which we've talked about, turns it into FM. An exciter is just a low-level amplifier, normally between 1 and 25 watts. Power amplifier, anything between 1 watt and 20 kilowatts, 20,000 watts. All right? FM stations in the UK vary between 1 watt and 250 kilowatts on air. 250,000 watts is a lot of power. How do you get 20 kilowatts to become 125 or 250 kilowatts? Antennas give you gain. They're passive devices, but they give you gain by stacking. It's effective gain. It's a trick of science. It's magic. Filters. The reason you have filters is you don't want to interfere with other signals, especially aeroplanes. There's a little green box there that says RDS, Radio Data System. Earlier, you saw the bit where it showed you things you can put on the radio, and they showed a DAB radio. How, modern, yes. With RDS, back in the 80s, you could put text on your radio then, radio text. You could put your name up, Classic FM. You can do that, and if you are in other countries which aren't regulated as well, you can also have scrolling text, which will give you this. Oh, and of course there's pirate radio, which does do that as well. Very quickly, pictures of transmitter. There's one I took of BBC Radio Bristol when we went down and did that one. 2 filters on Classic FM in the Isle of Man, and there's a prize. I'll buy someone a pint if they can tell me where that is, and go on, Mr. Thorpe, if you're here. No?
Is that the Coptoke transmitter?
No.
Nice guess, though.
Yeah, good effort. Yeah. No. Right.
Okay, so I'm going to very quickly talk about DAB and I suppose what makes it different to FM and kind of how it's created, which is a very different process actually. So when it was invented, one of the things about it was it can be more efficient from a spectrum perspective. That's because it can be transmitted on one frequency. You can get a bunch of services onto one frequency, which I'll come back to in a second. Obviously, really good audio quality. That was one of the things it was sold on as well. And you can put a bunch of data with it as well. Who's laughing at that? Come on. Jesus. You can put a bunch of data with it as well, so you can have all the now playing stuff that FM had, but you can also have like pictures. You can even have video with it. Not that that really took off either. And the signal is can be very robust too, and I'll tell you why in a second. Here's I heard that. Here's roughly what the system looks like. It's kind of different to an FM system because before you get to that, so you've got your audio in your studio, obviously, you've built all that stuff we talked about before. You need to encode it into MPEG-1 layer 2 or AAC, MPEG-4, before it goes into the multiplexer, which takes a bunch of audio services and puts them into one stream. So that, I don't know if you know what a multiplexer is, it's a weird word, but that's what they all do, regardless of whether it's a DAB multiplexer or something else. It takes a bunch of stuff, puts it into one thing, and then it'll send it out to a number of transmitters. Before it can get into that multiplexer, like I say, it has to be encoded into MPEG-1 layer 2. That means you need to digitize it. So this is like quantization stuff, really. But you need to describe the audio in terms of bits. That's just analog to digital stuff. And then on the right-hand side here, we've got a little bit about what MPEG-1 layer 2 does. So it compresses the signal by getting rid of a bunch of information. The information that it wants to get rid of is information that it doesn't think that you'll be able to hear. So it's based on a psychoacoustic model. So yeah, so if it figures that it'd be able to throw away a bit of that audio and you won't notice, that's what it does. Right, so then you got a bunch of audio services, you got a bunch of data services. This is kind of not a real diagram. In a way, it's a real diagram, obviously, someone made it. It doesn't accurately reflect what the subcomponents of an ensemble do. But anyway, in theory, it takes all these bits and pieces of audio and data, packages them up, puts them in the ensemble. That's what the kind of multiplexer kind of creates. And you have a certain amount of space to do that, 0 to 863 capacity units, which is arbitrary, but it just means there's only so many services you can put onto one frequency. Okay. COFDEM, anybody know what that means? Yeah, I didn't think anyone. If you don't know what RF means, good luck with that. It's coded orthogonal frequency division multiplexing. All know what it's about now, don't you? Anyway, it's a different kind of modulation scheme from FM. So in FM, we've got sort of one carrier signals. I mean, there are some sub-carriers, but let's forget about that for the time being. So you've really got one carrier. Here you've got 1,536 carriers. And your ensemble that your multiplex has just created goes across all of those. And that's one of the things that kind of makes the signal more robust. So it takes care of a problem called multipath, which is about FM signals bouncing off each other, arriving at the receiver at different times, and then creating distortion. The idea here is with all those carriers, when it bounces off other stuff, the receiver puts them together in a complementary way, so they can actually perhaps even have better reception rather than worse in that kind of environment. So then, if you're going to do a single frequency network, which you don't have to, but you can do, and so most of all our national networks are single frequency networks, so the BBC's MUX and D1 and SDL. So if you're going to do that, you have to worry about time a lot, because they all have to have the same view of time. They have to push out their frames, ETI frames is what they're called, push them out at exactly the same time. And then the receiver has to kind of receive them within an interval. So it has a little bit of room forever, a little bit of room for error, which is 24 microseconds. 24 microseconds is 75 kilometers in time, and that kind of defines how you space your transmitters in a single frequency network. Just a little bit on that anyway. Then the other thing is, I mentioned it briefly before, is we've got DAB Plus now. Everything that I've just said is exactly the same, except you have a different encoding algorithm at the start, using, like I say, MPEG-4 AAC. It just means you can get a kind of higher quality audio into less amount of space. And that's it. Any questions?
MPEG-4, what is MPEG?
Okay, so it's like an umbrella term, I suppose, and so is AAC for a bunch of compression standards.
Motion
picture experts group is
yeah.
But that kind of doesn't really mean anything. It's a family of encoding techniques, I suppose.
And is that related to JPEG?
Okay, so that's a good question in a way, because I suppose what I said before was bollocks. So I suppose, yeah, all right. So whilst it describes a family of encoding stuff, it comes from a body that's kind of created and agreed those standards, and I suppose that's what JPEG is as well.
If there's so many families of ways of compressing data, why have we used MPEG in DAB?
So...
Right.
Because it's brilliant.
Right.
All right? That's why.
DAB started possibly before some of you were born. The first DAB transmitters went on air in the UK in 1995, okay, and they'd been working on DAB for a number of years before that, and MPEG layer 2 was at the time one of the most efficient coding methods. Processors have got faster, technology's leapt away. Now you've got AAC, which allows us to do DAB+. Had we had known then what we know now, we'd have never used MPEG-2.
Yeah, but you can't predict the future. We had to choose one. That was one of the best ones at the time. You know, might have made a different choice today.
And that begs the question, will the UK industry ever switch to DAB+ when there's so many legacy? Throw them away now and buy a DAB+ radio. Come to TechCon.
I was just about to ask about the DAB+. So the established stations like Radio 1, Radio 2, they broadcast in standard DAB.
Yep.
But you've got spin-off stations like Virgin Anthems, Virgin Chilled, broadcasting in DAB+. Do you think that there'll be, as the technology improves, that we'll move away from standard DAB on the sort of like the heritage BBC and local commercial stations, and they all move over to the DAB+ format as the DAB technology gets better?
So the great thing is technology doesn't need to improve that much. All of the transmitters that we put out there already can support DAB+. And actually most of the encoders that we have in places can support DAB+ too. There's some software upgrades required in Arqiva land to make everything DAB+ capable, but it's not so difficult. So it's more of a question about what do the broadcasters want to do, and also what do you guys want? Have you all got a DAB+ receiver? No. So if you go DAB+, you're getting rid of some of your audience in a sense right now. But yes, there definitely will be more DAB+ services over the next few years, and I assume receiver sales will, there'll be more penetration of DAB+ receivers too. So that will happen, yeah.
Thank you very much.
Thank you.